In this video, we're going to talk again about proportions and specifically about setting up proportions from a word problem. Notice I said we're going to talk about setting up proportions from a word problem. I'm actually not going to be solving them in this video because I'd like to just focus on translating from words to mathematical language. Our first problem says, if you can buy 1 can of pineapple chunks for $2, then how many of them can you buy with $10? To some, this may be a fairly trivial problem, but it's always good to start with maybe a trivial example before you look at something more complicated. So let's say here, the ratio I know to be true is that I can buy 1 can for $2. Okay, this is a ratio I know to be true. For every 1 can, I have to pay $2. That is a true ratio. Now I'm looking for an equivalent ratio that involves spending $10 and buying X number of cans. Okay, this is one most people can do in their heads. If I'm spending 5 times as many dollars, I'm going to buy 5 times as many cans, so it would be 5 cans for $10. Let's look at another example. This problem says, Ming was planning a trip to Western Samoa. Before going, she did some research and learned that the exchange rate is 6 tala for $2. How many tala would she get if she exchanged $6? Okay, so they give us a rate or ratio here. The exchange rate is 6 tala for $2. So if she were to exchange $6, okay, we need to correspond the dollar amounts in the denominator. How many tala would she receive? Okay, that's our unknown. So here, we're corresponding tala between the numerators and dollars in the denominator. This is the rate we know to be true. This rate on the left is the rate we know to be true, and the rate on the right is the one that we are looking for, the one that is unknown. In question 8, if you can buy 4 bulbs of elephant garlic for $8, then how many can you buy with $32? So if you can buy 4 bulbs for $8, how many bulbs can you buy for $32? Again, the dollar amounts are in the denominator and they're coordinated, okay? The bulbs are coordinated in the numerator. And on the left, I have the known rate of 4 bulbs for $8. And on the right, I have the known dollar amount of 32, but the unknown number of bulbs, so the unknown rate here. Our next example says that the money used in Jordan is called the dinar. The exchange rate is $3 to 2 dinars. So I already know that I have an exchange rate of $3 to 2 dinars. The question is, the unknown part is, find how many dollars you would receive if you exchanged 22 dinars. Now, should I put the 22 dinars in the numerator or denominator of my unknown rate? Well, because dinars is in the denominator here, I need to also put it in the denominator on the right, leaving my unknown dollars in the numerator of the right-hand side. The next example says, Mary reduced the size of a painting to a width of 3.3 inches. What is the new height if it was originally 32.5 inches tall and 42.9 inches wide? Now, it's not explicitly stated in this question, but given that we're dealing with proportions, I would assume that they mean that the new painting, the size of the new painting, is proportional to the original. Okay, this means that we've essentially shrunk it down to be a miniature version of what it was before without changing the ratio of the side lengths. So the original height, h, is 32.5 inches, and the original width is 42.9 inches. The new width is 3.3 inches, but the new height is the unknown value, so I'm actually just going to call that h inches for height. We can actually set this proportion up in different ways as long as everything is corresponding. So if I have a proportion that has new height over new width, I would need to set that equal to old height, because I need the heights to correspond in the numerators, over old width. So then the widths would correspond in the denominators. Another way we could set this up is old height over new height equals old width over new width. As long as height and height correspond and new and old correspond in the same direction, you're fine. In the first method, the new dimensions are in the same fraction and the old dimensions are in the other fraction. Then both the heights are corresponding in the numerators and both the widths are corresponding in the denominators. It's also okay to do it the way I've done it here in red, where the old dimensions are corresponding in the numerators, the new dimensions correspond in the denominators, and the heights and widths correspond in the same fraction. As long as there is correspondence up, down, and left, right, everything will be fine. So I'll show you what that would look like set up in both methods. New height h inches over new width 3.3 inches would equal the old height 32.5 inches over the old width 42.9 inches. Okay, so that's one appropriate way to set it up. Another way, written in red, is that we could do old height 32.5 inches over new height h inches equals old width 42.9 inches over new width 3.3 inches. Cross multiplying or clearing a denominator for both of these will get you the same answer. We have one final problem to discuss today. Asanji took a trip to Mexico. Upon leaving, he decided to convert all of his pesos back into dollars. How many dollars did he receive if he exchanged 42 pesos at a rate of $5.30 equals 11.1 pesos? We're given a rate and we have an unknown number. So our rate is that it's $5.30 equals or for 11.1 pesos. Now we know the amount of pesos he exchanged on his way back from Mexico. So we're going to put the pesos in the denominator of the fraction on the right to correspond with the pesos in the denominator on the left. And the unknown value is up here. We do not know how many dollars he got back for those pesos, but we have the dollars corresponding in the numerator, we have the known rate set up properly on the left, and everything on the right corresponds to it. So this would be a matter of clearing the denominator of 42.7 pesos to solve for x.